when you divide with synthetic division, you can only divide by a linear, I don't know why I gotta lock this page here, hold on here. Lock, rotation, okay. You can only divide by a linear term. So every time you're dividing by a linear term, you're able to say, oh, set that equal to 0, x can be a -4, so I divided by a -4. So you can only do that when you divide by a linear term. Do I need to do another one of these to remind you what we were doing?
Could you do one so that I can get what we're doing?
Because you weren't here?
Yeah.
Uh-oh. All right. Start with the hardest one. The hardest one because they'll tell you what's wrong. What's wrong with this x to the 4 minus 9x cubed minus 1?
It's missing a power.
It's missing a term. If you start with the fourth degree, you got to go 4, 3, 2, 1, and 0. Yes. Yes. So there's a 4, there's a 3. I'm missing the x squared. Wait, I'm missing another power. I don't have anything with an x. That would be an x to the 1. I don't have one of those in here either. And I do have the -1. That -1 would be a -1 times x to the 0. So I have the 0 power. So what do? Tell Elena what I do if I'm missing those powers.
You add a 0. It's like hold it.
We hold it with zeros. And so you didn't get to see synthetic at all? Okay. You did probably in Algebra 2, so hopefully it'll come back. So I'm going to divide by the opposite of x minus 9 would be x has to be a 9. Because if I set this equal to 0, add 9 to both sides. So this 9 goes outside, and then these coefficients are what I need. So I have a 1, a -9, I don't have an x squared, I don't have an x, then I have a -1.
Okay.
Now you remember seeing this? And then what do? The first step you do is you just bring down the first term, and then you got to take this 9 and multiply by the 1. What is 9 times 1, Lorena? What is 9 times 1? And that goes up here. Then we add straight down. That gives me a 0. Always add straight down. Always add straight down. Now I got to take 9 times 0 is what?
0.
0. Add straight down. 0. 9 times 0 is 0. Add straight down. 0. Not very exciting. 9 times 0 is 0. Add straight down. Leaves the -1. So what was he asking us to do? Let me get the whole directions. Just divide using synthetic division. Okay, so since I don't have a 0 here, the answer will be 1x to the 3rd power because you always start one less. But I have no x squares, I have no x's, and I have no coefficient by itself. So the answer is just an x cubed, but I have this remainder. So it's -1 over x minus 9 would be the complete division. It's just not very exciting. We're going to do more synthetic division as I move on here. We had learned, well, probably in our next lesson here. The whole reason that we're doing synthetic division is it helps us factor a polynomial. And what I do with this, I'm going to take this f of x, 3, it's missing there's a 2, there's a 1, and then there's no x's at all. And he wants to find out if x minus 4 is a factor. So the secret is this. The opposite of x minus 4 would be just a 4. Do you understand why I'm getting the opposite of a -4 is 4? That's going to go into a 1, a -5, a 2, and an 8. How do I know if it's a factor? I mentioned it already to everybody else, but I don't know if they remember. What's the secret that I know it's a factor? Remember what I did? At the bottom here, if I get a 0, it means that x minus 4 is a factor. That means x minus 4 goes into this polynomial, which tells you that if x minus 4 is a factor, and you set that equal to 0, then I know x equals to 4 is a 0. So if it is a factor, then we found one of the zeros. And since it was a cubic, I could have 3 zeros.
Wait, where did you get the 0 from? Did you just put it there?
Yeah, I just put it there. If it's a factor, it's like, remember when we factored our quadratics, we always said it was this times this has to be 0. I'm going to do a simple quadratic. X plus 2, x minus 5 equal to 0. Then we said, well, that's my polynomial being equal to 0. That's my f of x being equal to 0. Then I set each of those to 0, and I get x is a negative 2. X minus 5 equals to 0, x equals to 5. Those are my zeros of that quadratic.
So because it's x minus 4?
Because it's if I do get a 0, then I know x equals to 4 is a 0. You could graph it on your calculator, and you will see that the function crosses the x-axis or touches the x-axis at 4. I don't know if it's going to bounce off or not. 1, 2, 3, 4. I mean, it could do this, nice and pretty, and bounce off, or it could literally go right through the negative 4. Could do either, and not negative 4, positive 4. So I'm over here. Let's see. I don't know if it is or not. I think there is. And then once we get done, determine the zeros of the function. They want me to find all of them when I get done. You already found it is a 0 there? Okay, let's try it. 1, 4, negative 1, negative 4. What comes down now?
Negative 2.
Yeah, negative 2 times 4, negative 8. Yeah, so therefore, x minus 4 is a factor. Let me get rid of this other stuff so I have more room here. I need more room. And it's not erasing, so I gotta go, okay. I could have just zoomed in and made more room there, but this is more fun. So I found one of my factors. And since it's a cubic, it is possible this is the only real factor that I have. The rest are like imaginary. But chances are there's 2 more, okay? And each of those will be set equal to 0.
What do you mean imaginary?
We haven't done those yet. It's like, what if I end up having x squared plus 4 equals to 0? And you had to solve that. And if you move the 4 over, that gives you x squared is a negative 4. Then I hit square root. What's wrong with the square root of a negative? Can't square root a negative, so it's not a real number. It's an imaginary number. It would be x equals 2 plus or minus a 2i.
We haven't done that yet?
We've done this, but we haven't found the imaginary zeros of a polynomial.
Like in this context?
We have not done it in this context, that's right. But it's coming, okay? So now that I found one of the zeros as x is 4, x has to be 4, he wants the rest of them, if there are any more real ones. But what happens is, what I didn't share with you, is that the leftovers here is another polynomial. Because this is going to be an x squared, this is a minus x, and this is a minus 2. Because you always take the leftovers and you start with 1 degree less than you had at the beginning. So it was a 3. So this is a 1x squared minus 1x minus 2. So then set that whole thing equal to 0. Now we could also do more synthetic division if we had more tricks in our hat. But this is easily factored. I'll bet you half of you can factor it right now in your head. What 2 things can I use that'll give me x squared? I'm going to write it up here. I don't want this one no more. I want x squared minus x minus 2. How can I factor that and fill these 2?
Negative 2 and positive 1.
I think I agree. X minus 2, x plus 1. So if that's true, which I think she's right, because that's just the way she rolls. She's right, because she knows what she's doing. And I don't think she knew she was that good at math before, but she is. That means another 0 would be, if she said this was x minus 2, then one of them is x is 2. If she said x plus 1 is a factor, then the other 0 would be x equals a negative 1. So I had my 4, I have my 2, and you could actually put it in the symbol like this: 4, 2, negative 1. Isn't that how we showed our zeros before? Yeah. So there they all are. If you can get one out by synthetic division, hopefully your polynomial is factorable. If it's not factorable, then you have to use the quadratic formula. If you use quadratic formula, you could get answers that are not even rational. Rational means it's not really a fraction. For instance, the square root of 5 is not a rational number. There's no way to write square root of 5 as a fraction, a number over a number. Because when you put it in the calculator, the decimals go on forever and ever and ever. There's no pattern, there's no repeat. So you can't turn it into a fraction. So x minus square root of 5 could be one of the factors. That's not a rational factor. These are rational. I know most of you are saying, so what? Yeah, I know. Let's do another one. He says, given this polynomial and one of the factors. So he's telling me that I'm giving you a factor. Thank you very much. He wants me to use synthetic division to find the rest of the zeros. Since he's already told me that this is, the only reason I am doing the work by dividing by the positive 7, and I put a 1, and I think I'm missing a square term. 0, negative 37, negative 84. The only reason I'm doing this, because when I get done, I should have a 0 there, because he told me it's a factor. That means x equals to 7 is a 0, right? See that? Is a 0, is a 0 here. The reason that I am doing synthetic division is to get the leftover garbage right here. I need the leftover garbage. The leftover garbage will be a quadratic, and I can factor it.
So, to start, you bring down the first one? You bring down the first...
Yeah, go ahead and lead me right through it. Go ahead.
Oh, okay.
Bring down the first one. Now what?
Okay, and then you multiply that by the one in the corner, which is 7?
And that gives me, and I put that answer where?
Under the 0.
Nice. Now what?
You bring that down?
Do I bring it down or do I subtract?
Oh, you subtract. You add.
I lied.
Add?
I add.
Okay.
I tricked you. 7.
7.
Now what?
Okay, so then you multiply that by the 7.
Okay, gives you how much?
49.
And that goes where?
Under the negative 30.
Okay, keep adding. Positive or negative?
Positive.
Positive 12, okay.
And then that times 7.
And who knows what 7 times 12 is, right? I mean, 7 times 2 is 14. Carry a 1. 7 times 1 is 7 plus 1. 8, it's an 84. Surely, look at that. They cancel out. So the reason I did synthetic division, I already knew it was a factor because he told me it was.
But you need the bottom.
Yeah, this turns into 1x squared plus the 7x plus a 12. Set that equal to 0. And I hope it's easily factored. And I think all of these are going to be easily factored because he's not trying to trick you right now, or she. It was a woman. And she wrote this stuff. I can show you her picture. It's on the top of the curriculum. But
3 times 4.
what is it?
3 times 4.
You are the factoring queen. And since there's a 1 here, then there should be just an x and an x, right? Mm-hmm. And she said a 3 and a 4? Yep. Positive or negatives?
Both positive.
Both positive. Positive 3, positive 4. So,
Wait, so I have a question.
yeah.
Technically, could you do negatives or no?
You could do negatives, but
Like both negatives? Because it's adding...
but then they'd add up to negative, and this thing would have to be negative,
Oh, okay, that's right. Okay.
right? So this says, if I want to be honest, then he said find the zeros. my f of x that I started with is the x plus 7, is the x plus 3, is the x plus 4. They all multiply together to get back to the original problem. So now that I have all three factors, which it is possible to have three if a cubic, then my zeros are, you tell me what my zeros are going to be.
X minus 7, right?
Oh, was it?
Yeah.
Oh, yeah, it is. It is a minus 7, yeah. So what are the zeros?
7,
7,
negative 3.
negative 3,
Negative 4.
negative 4. So that's the gist of why we do synthetic division. Yeah, it was nice he gave us a factor. You know, the next time we meet, we're going to do where we don't know any factors. And then we got to do that magic, you know, fraction over a fraction. I think I mentioned it one time to you guys before the 9-week test because Mr. Doherty already taught that. We're a little behind, but we're not as far behind as Mr. Pemberton. So, not that I'm competing or nothing, you know. I think he's going too fast, and I think he's going too slow. I'm just right. Yeah. Do one more. We know that x plus 3 is a factor. So I got a 3, 2, 1, 0. That means I don't need to fill any holes, do I? So the opposite of plus 3 is a minus 3, going into 2, negative 3, negative 32, negative 15. And when I get done, I better have a 0 here. I better, or I made a mistake, since he told me that it was a factor. So, Lorena, what do I do first? What's the first step? Bring it down. Did you hear her? Now she's going to ask you, bring what down? Bring the 2 straight down. That's right. And 2 times a negative 3 is what, Christian?
2 times negative 3?
Uh-huh.
That's negative 6.
Where does it go?
What do you mean, where does it go? It goes down?
Where do I put the number? Where do I put the negative 6 at?
Oh, to the right of 2.
Nope. Well, it is to the right, but it's actually up here. It's actually here.
Negative 6.
Negative 6 goes here.
Negative 9.
And then I add straight down again, negative 9. Miranda, what number goes here?
27.
A positive 27. Nice job. And Kendra, I'm missing one more number. What goes here? What goes in that blank right here, Kendra?
5. Right.
You have to add straight down, Kendra. And I have a lot of negatives. You caught your mistake. More negatives than positives. So you subtract them and keep it negative. Negative what? 5. And then I take that negative 5 times the negative 2, or 3, I'm sorry. That turns into a positive 15. And yes, it does give me a 0 here. So it does check out that f of x does have this factor of x plus 3. Now I have to find the other 2 possible factors because it was a cubic. So what I do is I take this 2x squared because, again, that's a cube. So I take 1 less minus 9x minus the 5, set that equal to 0. And
Times negative 10.
Yeah, 1 and negative 10.
are you sure?
2 times 5 is,
Oh, you're already doing the correct factoring?
yeah.
Okay. I didn't know if anybody's going to notice that this is not, we're no longer in Kansas now. You have to factor this,
AC method.
the AC method, right. 2 times 5, or it was a negative 5, wasn't it?
Yeah, it's a negative 10.
2 times a negative 5 is a negative 10. Factors of a negative 10 that add up to a negative 9.
1 and negative 10. 1 and negative 10.
1, perfect. 1 and a negative 10 do multiply to get a negative 10. And when you add them up, you do get a negative 9. So what we have to do is those 2 turn into a 2x, put a 2x and a 2x, because that's what we have here. And we go the 1 and the negative 10.
But
But what?
you can simplify it.
Solve it.
The 2x minus 10 has an extra what that they both have? Throw it away. So my factors will be 2x plus 1 right here. And this one will be, if I factor out the 2,
X minus 5.
x minus 5 will be the true factor. If you forget to do that and you use the whole thing, that's not exactly a factor, but it'll still give you the same 0. Since all he asked for, or she, was find the zeros, you could have said 2x minus 10 equal to 0. Would have been fine, because look what you get. Add 10, 2x equals to 10, divide by 2, x equals to 5. Look what happens up here. What are my zeros up here? What's this one give me? This one right here.
Negative 3.
What does this one give me?
1.5.
No.
A half?
No. Yes. A negative half.
Oh, yeah.
What's this one give me?
5. Positive 5.
And so what I was telling you is if you accidentally put the wrong factor up there because you forgot to simplify it, you'll get the correct answer still. Because I did get a 5 right here, see? The 0 is the same. The factor was different. But it's okay. You know, we're learning. All right, let's move on here. This is a homework assignment on using synthetic division. So let's see. I think for the other classes, I think I assigned the evens off of homework number 5. And I don't think I'm going to get enough done to do homework 6. So I may have to pause my recording and I finish it up at home so that you can finish up a couple problems. I think I assigned half of them on 6, I think. But let's see. In the next set of notes, we start out by dividing again, right? We just got done doing it. But I want to show you something, huh? Oh, you don't have that page. Anyway. So let's do the division real quick here. We should be really good at it. Opposite of plus 4 is? So really quickly, I'm going to divide by negative 4, and I hope there's no missing terms. 1, 1, negative 4, 4.
Wait, what?
1, 1, negative 4, negative 4. Oh, positive 4. Yeah.
Is that 41?
No.
Why not?
Oh, yeah, it is 41. Yeah. I couldn't see it. All right. Bring down the 1. And a negative 4 times 1 is a negative 4. Negative 4 plus 1 is a negative 3. Negative 3 times 4 is a 12. 12 minus 4 is 8. 8 times a negative 4 is a negative 32. What's 41 minus 32?
41 minus 32.
9.
Bummer. That means this is not a factor because this is not 0. But what if I asked you to find f of a negative 4? How would you do it?
Plug in the x's.
Okay, so f of a negative 4, plug it into the x's. Negative 4, make sure you put a parenthesis, cubed, plus a negative 4 squared, minus 4 times a negative 4, plus 4. And you know, I'm not enjoying this. I hate doing this because I make so many mistakes. But keep me honest here. A negative 4 times a negative 4 times a negative 4 will be a negative, because I know there's 3 negatives. 4 times 4 is 16. 16 times 4 is 64. And then a negative 4 squared is
16.
16 plus 16. And a negative 4 times a negative 4 is
6.
another 16 and a plus 4. So I'm looking at a negative 64. Let me add up all the
Plus 41.
41.
Yeah.
Why do I keep losing that 1? I don't know. So I'll keep the negative 64. It's the only one that's negative. 16 plus 16 is 32, still plus the 41. Now I think I can do the negative 64 plus 32. How much is that? Negative 64 plus 32.
Negative 32
Negative 32 plus the 41 is how much?
is,
It's magic. What'd you get?
negative I mean 8.
No.
9.
9. Where have I seen 9 before?
Oh, yeah, 9.
On that one.
Is it? It's right there. If you don't get a 0 there, even if you do get a 0 there, that's what you get when you plug into it. That's when you substitute that x of a -4. It's a simple way of finding a polynomial value at a particular number by using synthetic division. And we call that synthetic substitution. Because what you really did here was substitute, right? All you did is substitute a -4 in place of x. So synthetic substitute. This was so much easier to me than this. But I had students who disagreed with me yesterday.
No, I still find that really,
You what?
I find that really easy.
You love the regular substitution.
No, I like the synthetic division.
No synthetic division.
Oh, you like the synthetic. I like the synthetic.
Yeah.
It just takes a little bit of practice though. So now, I'm not going to play that game again. He wants f of 9, because if I take x minus 9 and set that equal to 0, x is 9. So I know when I get done dividing by a 9, and the coefficients are a 7,
63.
oh, is it a 63 or a negative 63?
-63.
Negative 63, and a what?
0.
Oh, a 0. Good catch. 9 and a -80. When I get done, this answer right here will be f of 9. It's a miracle of modern mathematics. Truth is, this was discovered hundreds of years ago by somebody much smarter than me. But they couldn't get a date on a Friday night. That's their problem, you see. When you can't get dates, you end up having to invent more mathematics. What else is there to do, right? 7. 9 times 7 is 63. And a -63 plus 63 is how much? 0. 9 times 0 is 0. And 0 plus 0 is getting boring. 9 times 0 is
9.
no. 9 times 0 is,
Oh, 0 I meant.
and now when I add straight down, I get a 9. 9 times 9 is
No, 81.
81. 81 minus 80 is,
1.
therefore, f of 9 must be a 1. Now, plugging in a 9 in this problem, for those people who say, oh, I love the old-fashioned way. Okay, the first thing I'll ask them, 7 times 9 to the 4th power. Okay, well, what is that in your head?
I'm not fast.
I don't even know what 81 times 81 is in my head. Do you?
No.
Because 9 times 9 is 81, so I have 4 of them. 9 times 9 times 9 times 9. 81 times 81. What would I have to do to get that answer? Probably pick up my what?
Calculator.
Or scratch work. 81 times 81, 188, 64, 116, 5, 6, 6, 5. Why would I want to do that? So,
Wait. Don't forget.
what?
Times 7.
Oh yeah, I didn't even times it by the 7 yet. Times 7 now. And the odds are, I already made a mistake.
Oh.
I mean, probably. Well, I could pick up, and I had a girl, she's really fast yesterday. She could plug that in her calculator, the Inspire, because there is a secret way to do the other calculator, the one that you borrowed, that you can put in the function and tell it to actually plug in a 7, or 9. I don't know how to do that with the Inspire. I'm going to look it up online tonight.
Wait, like just like plug in that.
Just plug it in without having to type it all in. I mean, yeah, you could type this all in. You could type this all in, minus 63 times 7 to the 3rd. Yeah, you could type that in, but there's got to be a way not to have to type it in like that. But
Yeah.
9 to the 3rd.
I'll figure it out. So anyway, remainder theorem. If a polynomial function is divided by, arbitrarily, I'm going to say x minus some number, then the x equals to that number, whatever that number is what was he wanting? Is a fact, no wait, x equal to c is a 0. I think that's what he's saying. Using synthetic division to evaluate a function is called synthetic substitution. Wait a minute. No, sorry. If a polynomial function is divided by x minus c, then the x equals to c. It's not a 0. I don't know what I want. I don't know what she wanted. Oh, no, I know what it is. I know what it is. I'm trying to think, trying to read her. Oh, why am I erasing all that?
So what is it?
I'm going to do this. I want to erase this. What are you looking at?
Order. Right.
I don't want to write this up. I want to say, oh, come on. I want to say, then F.
Did you have the MCQ with you?
It's on the computer, and I have to go to like page 400. And, oh, what word was it? Oh, wait, maybe. Divided. If I divide it by x minus c, then f of c it's the remainder. That's what it was. F of c is the remainder. That's the remainder. Okay, that's what it is. I just can't read her mind, what she was thinking. And when we do it, synthetic division, we call it synthetic substitution. So she wants us to practice it again. So she's being nice.
Wait.
Yes.
It's then the f of c?
F of c is the answer we get right here. Like f of 9, this was,
Wait, what does that be wait, is that the remainder?
that is a remainder.
So wouldn't it be then the remainder is f of c?
Yes, that's what I wrote. F of c is the remainder is f of c. Goes both ways.
Oh, okay.
So you said exactly the same thing, just in the other order.
Okay.
So if c is already given to me as a -3, she could have just said x plus 3 is a factor, right? She could have just said that. But we already know that we're looking for c as a -3. So -3 going into 1, 8, 12, -7, and a -14. It's a lot. I mean, it's a 4th degree, so it's a lot. A lot of work. So the trick was, bring this one down, multiply, -3. Class, what's 8 minus 3?
5.
That wasn't the whole class. That was 2 people. Try it again. 8 minus 3.
5.
If I got to act like I'm alive, so do you. 5. -3 times 5. Okay. 12 minus 15.
-3.
Okay. I think I'm only getting still 2 to 3 people.
9. Which is.
Wait, hold on. I want the compliment yelling out. Those that just gave me the answer, you don't say nothing this time. -3 times -3. You see, they are alive. Still stay quiet. -7 plus 9. That's one more person added to the choir. -7 plus 9. The same person. -7 plus 9. Okay, got a few extras. 2 times a -3. All right. -14 minus 6. It is a -20.
Remainder.
That's the remainder. So I can say that f of the -3 is -20 without having to plug it into all those numbers. I don't think that'd be fun. I just don't think it'd be fun to plug in a -3 4th power, 8 times a -3 cubed, plus 12 times a -3 squared. I just don't think that would be any fun. Because this was barely a little bit of fun. I'm not going to say, well, I can't wait to go home and tell my wife that I did this today. It's not that much fun, but it was okay. All right, number 4.
It's kind of easy.
It is easy. I'm going to divide by the 1, going 3. It's a 5th degree. That's a big, ugly, high-power polynomial.
There isn't any missing powers.
What's missing? 2. Oh, there is none. Okay, good. Thank you. 4, 3. Then I'll do it faster. 2. I'll take your word for it. Okay, so doing a 1 is pretty easy. Even plugging it up there, it's not that bad. I could probably do it in my head, but that doesn't mean I won't make a mistake. 3. 1 times 3 is? 3 plus 2 is? 5 times 1 is? 5 plus 4 is? 5 times 1 is? I tricked you. It's 9 times 1, right?
It's still
9. Well, yeah, the answer was right, but I gave you a different problem and you didn't even pay attention. What am I gonna do with you guys? 9 plus 3, 12 times 1.
Huh? That's not 12 times 1, it's 12 times... Wait, what?
Yeah,
Okay.
12 times 1.
Okay, yeah.
And then 12 plus 2,
14,
14 times 1.
14,
14 minus 3.
11.
There's your answer. F of 1 will be 11. That's called your remainder theorem because you're using the remainder to evaluate a function. I think it's cool, you know?
But this can only be done when they give you the C?
Yeah, well, or a